Great. Finally, we're here. This is binding the C. I'm going to talk about creating Python bindings for C libraries or C-like libraries. So, hello. My name is Åke Forslund. I do work for a company called Mycroft AI. We're trying to launch an open source virtual assistant similar to Alexa and Google Home and similar. This is me ice skating. It's not very stable. It's very much trial and error, which is very much like my work. I try stuff and I fail, I make mistakes, I learn. Pretty much like many of you, I guess. So this talk is about binding C or external libraries to Python. This is often called foreign functions interface, which is a term coined by Common Lisp way back in the day when they wanted to call C function and Fortran and whatever they called back in the days. So the story about this talk is I originally submitted it for last year's conference when I had done some work with ctypes. And they asked me if I wanted to do it this year since it was cut last year. And I started doing my research again and trying to remember what I actually did last year. So I started looking at ctypes again. I thought after like doing 5 hours of creating an example and testing and stuff that I wonder if there's anything else besides ctypes. And I found CFFI, which is much more modern. So this talk is gonna first talk about ctypes, and then we're gonna talk a bit about CFFI. So ctypes, it's included in the Python standard library. It's sort of verbose. And CFFI is a bit more modern. It comes from PyPy. It's simpler, and it has something it's called an API mode, so which we'll hopefully go into later. Don't scare me like that. Okay, so libraries. Things starting with lib and ending with .so in Linux and often in the Mac world as well. And in Windows, we have the DLLs. These are similar beasts, but they're not quite the same. So this talk is basically focusing on the Linux and Mac side and just ignoring the DLLs for well, you can do it at home. It shouldn't be too difficult. So when compiling a library, a shared library, you have to have the -shared as a GCC parameter, and this will make it a shared library, basic as a header, and give you some, make it callable. You also basically always need to add the fpic, which tells the compiler that the symbols in this file, they should be placed in a way so they can be relocated anywhere in memory, which is important since you don't want all your program calling into the same memory area when using a shared library. So you basically use copies of the code. And this is, of course, not only something that pure C can do. You can create these kind of things from C++ or Rust or what have you. And in C++, you will see some areas marked with extern C. And these areas will basically not be name mangled. They will in this case, the name no mangle will be available as a symbol in when you open the shared object. Okay. And now to the tricky part. I was gonna demonstrate the library we're gonna use for tests here.
We're not seeing what you're
No, that's all right for now. So this is C. This is not Python. This is something C programmers write a lot. This is a simple linked list. We don't have the list as a standard object in C. We have to either create it or use some obscure library, and libraries are hard, so most C developers write their own for whatever task they want to do. So we have something creating a new node. We have something creating a new list. We have something that can append to the existing list. And we have something to get an element by an index. And we also have a corresponding... No! Okay. Yeah, okay, we're back. But I can't control my window. And we have a .h file, which basically shows the interface of this C file, all the functions and all the types. So let's go back to the slides before we lose them. So C types, part of the standard library. It basically works by providing C or Python representations of C primitives. So you have in C, you have an integer type called int, and C types will provide a Python class called cint, which will work like a bridge between a Python type and a C type. So to get starting with C types, what we need to do is we need to load a library. We need to declare any functions that aren't standard. We need to basically their arguments and their return types need to be declared. So in this case, we use we include the library by file, which is /lib/liblist.so. This could also be, if this was installed in the system path, we would just enter list. So you would cut away the lib and the .so and just use that as a reference. So in this case, we say that new list returns a pointer to an element type, and the arguments for the append is you append an element to an int to an element. So you saw the element in the previous slide, which is also a ctype. It represents the element in the C code. In this case, this is a structure which ctypes doesn't know about, but ctypes implements something called structure. And in structure, you basically create a subclass and you add fields representing the struct members. So in this case, we have a struct with a value and a string pointer. We had the fields of a val, which is of type cint, and a string, which is of C# pointer. So you can see there's some sort of similarity between these two. Let's talk a bit about pointers. ctypes provides a pointer macro which takes a normal property or a normal ctypes representation and makes a pointer to it. And when working with pointers in C, you often want to dereference them to get the value that the pointer is actually pointing to. And this can also be done in Python in ctypes. And they have two different ways of doing this, just to be clear. They have a .content, which points to the contents that the pointer is referencing. They also provide the index method. And this is basically to emulate the syntax of C. This will, in C, object bracket 0 will basically dereference the first object in starting from that pointer, which is a bit weird, but it's if you know C and you want to get it similar, you might want to use this. I personally prefer contents because it's more explicit. Then we have possibility to change from one pointer type to another. In C, you often use the void pointer, which basically could be anything. It's just a memory address, and then you cast it to say, this is my element type at this location, and you will be able to dereference it as an element type. And ctypes can do that for you as well. You can have a void pointer, and this is an element, so let's call it an element. Then we have the third tricky thing with C, callbacks. So in C, you can send functions to other functions, so they can do a callback. And this is usually quite tricky to get right, at least for beginners. But you extract, you can, in this case, say that a C function or a Python function is a C function type. In this case, we have callback function takes no argument and returns nothing. So we just say cfunc type none as a decorator. Now I'm going to try to show an example where this is used. So this is Frots. It's an engine for running old text-based adventure games. And my example here is I hate that I can't see this. So it loads my dumb.so file, which is a representation of the dumb Frots interface, which is originally just a get character and put character interface, which I've overridden a couple of functions and added a couple. So in this case, whenever I've added a callback, so let's see here. So whenever the game engine wants to prompt me for information, we launch the prompt handler function, which basically prints the last data that was received to the virtual screen. And then we can get it to basically print out after each. Oh, laser. Excellent. So, and then we can just send it a couple of commands like open the mailbox, take leaflet. So you can basically have, you can script the entirety of Zork here, if you like. So this, getting the callback to work took me like 1 hour yesterday, which it's interesting when working with Python because you have a garbage collector. And the garbage collector only is aware of objects you keep references to in Python. So when you create a cfunc type, you can, if you don't use a decorator, you will need to keep a reference to it in Python, because if you only send it into the C world, Python will promptly say, oh, this isn't used anymore, let's get rid of it. So, yeah. Okay. This is the quick version of ctypes. It's pretty handy. It's a bit verbose. You need to basically learn a new dialect. You need to learn whatever the ctypes representation of C is. And it's, when you get going, it's kind of easy, kind of intuitive, but you have to write a lot of code for it to work. So moving on to more modern stuff. CFFI. Basically, the idea here is that you should only need to know Python and you should only need to know C to get going here. So anywhere where you in ctypes need to make some declarations and write like special syntax to get stuff interfaced correctly. Here you basically drop C code. So here we're doing the same thing basically as the first example for ctypes. We import FFI and we do our definition, which is basically the contents of my C header file in this case. And then I tell FFI that this is my definition of my C library. Yep. So, and then we open the library, and everything should be pretty good. So, structures. You don't have to do anything to declare structures because you use the C source. Pointers. There. CFFI uses the bracket 0 notation, and only that one. And then to cast, you have a ffi.cast function, which basically you declare a string of C code declaring the variable and the value you want to cast to that variable. Callbacks is also very similar. It's this is a function taking returning an int and taking 2 ints as arguments. So let's see an awkward example. Okay, here we. So here we actually start calling stuff. So this is the same as I showed previously, and here we have the linked list, and we create my list, a new list, and then we start appending to it, which should be pretty straightforward. So here we have oh, right. There we are. So here we see my list, which is of element type, and we have our linked list library representation. So we do a dir. We can see all the methods we have to work with. So if we do where? No. Thanks. And we get the second one. So now this is element T pointer, as shown here. So we can dereference it to get our element. And we can pair it, see what it contains. And it has the next element, and it has a value. So we can check the value, and it's a pointer to an integer, and we can dereference that as well. Hey. So now you can write instead of writing C code in C, you can write C code in Python. So, okay. The CFFI also provides an AP mode, which basically builds a C extension, and it's basically faster because you skip a step when calling each function. And let's quit this. Here, the beginning is basically the same. We create a definition. In this case, I read the linked list H file instead of typing it out again. Then we declare how to compile this stuff. We need to include the library there, and we need to include both its library position and an include for the header file. And in this case, since it's not in the standard library or in the system library, we need to tell it where it is in the system, so it works when calling. Okay, one final thing that should the final. So we can write C in Python, but we want to write Python in Python, right? So we always want to do something like wrapping our C calls in like a class. Here we have our C list, which we add functions to. You can append to it, you can check the length, and you can use standard index get item. And to do a del method, because C, it doesn't have garbage collection. If you don't remove things when Python removes them, then will just float around in memory and take up space and time and throw errors. So we're working with C here. We have segmentation faults, we have division by 0, we have a lot of things, and if these occurs in C when you're accessing a C function, your Python interpreter will basically be shut down as well. Okay, that's everything. Thank you for listening.
Well, thank you. We have time for one question already. So, anybody? Thanks.
Hi. Another option for doing bindings is Cython. Do you have any opinions about when you should use Cython and when you should use ctypes?
So, I haven't used Cython myself yet. What I feel Cython is more inlining C, and I'm not sure it's suitable when working with like big external libraries. But I could be totally wrong on that point. So.
Okay, thanks.